Alrighty folks, what we're looking at here is how to solve one of these calorimetry problems. This is page 5 of the thermochemistry packet number 3. And it states we've got a 150 gram sample of a metal at 75 degrees Celsius, and we add this to 150 grams of water at 15 degrees Celsius. The temperature of the water rises to 18.3 degrees Celsius, and we want to calculate the specific heat of the metal. I'm going to do this using specific heat in joules per gram degree Celsius, but it could be done just as easily using calories per gram degree Celsius. That would just give you a slightly different answer. At the end, I'll convert them to that. So the way this sets up is we're going to kind of make a table, one for the metal and one for water. And our mass of our metal is 150.0 grams. And we also have that as our mass of our water, just as a coincidence in this problem. So these numbers aren't always going to be the same. Then here we've got an initial temperature of our metal. So I'll call this Ti sub met for our initial temperature of our metal. Metal is going to start at 75.0 degrees Celsius. If we look at our water, our initial temperature of our water, our Ti for our H2O, is going to be 15 degrees Celsius. And then this water, its temperature is going to rise to a final temperature of 18.3 degrees Celsius. This water is not going to rise up any higher than the temperature of our metal, and our metal is not going to sink to any temperature colder than the temperature of our water. So our final temperature of the water is also the final temperature of our metal. So TF metal. That is to say, if this was colder than the metal at the final temperature, well, the metal would still be losing heat to this, which would cause that number to go up and the temperature of our metal to go down. So at our final temperatures, the water and the metal have the same temperature. And in this problem, we're looking for our specific heat of the metal. We don't know that, but we do know our specific heat of our water. We need to know this. This is comes in two forms. One is the 4.18 joules per gram degree Celsius, or if you were to do this using calories, 1 calorie per gram degree Celsius. All right, so then we're going to use our formula here. We're going to take our Q of the metal is equal to negative Q of our water. The amount of heat that the metal loses is equal to the amount of heat that the water gains. Well, we know Q is equal to MC delta T, so we're going to use the mass of our metal times the specific heat of our metal times my change in temperature of the metal. And we're going to set that up equal to our mass of our water times our specific heat of our water times our delta T of our water. To find our delta T's, we're just going to do the difference between these, final minus our initial. It means our metal is going to have a negative delta T. Our water is going to be final minus initial. It means we're going to have a positive delta T. This just means our metal lost heat, our water gained heat. So I'm just going to rearrange this equation just using a little algebra, and I'm seeing that I'm limited to 5 minutes per video, and I'm running down to a minute. So I'm going to pause this and show you what the formula would look like when we rearrange it to solve it for our specific heat of our metal. So all I've done is rearrange the equation, and we get our mass of our water times our specific heat of our water times our temperature of our change in temperature of our water, all divided by the mass of our metal and our change in temperature of the metal. So again, because time's pushing, I'm going to pause this and put those numbers in there for this. I'm back. One thing I forgot before I went away was the negative sign. I forgot to carry down there, and I forgot to carry it down there. So then our negatives, notice, we're going to cancel those out, so our specific heat will be positive. And if we do this, we're going to find that our specific heat for the metal is 0.24 joules per gram degree Celsius. If I were to do this in calories, the only difference here, this number would be 1, and we would end up with 0.0574 calories.